K2?
So just a few years ago, the problem in decision making typically was not having enough data. In a short decade, this problem turned on its head, and today the biggest problem is having too much data and filtering this data to get decision-making information, actionable information. What digital twins can do for you is filter this glut of data and find the nuggets of information that you need to make a decision. So by linking your SCADA to digital twin to K2, by linking your GIS to K2, you have ability to create a decision-making tool that will help the operators, that will help managers make the best decision possible given all the available data combined with a predictive model. So when you connect the digital twin, when you connect K2 to external data sources, you have a couple of choices to make. One is how good your model is and what data has already been linked to your model before the model was linked into K2. And the second one is what kind of decision do you want to make? So if you are an operator, you probably might give more preference to SCADA data because that will tell you what's happening in the system right now, where managers might think more about representation of the current system or representation of the future system and might prefer to link to GIS. Therefore, the decision of what data to link to K2 really will depend on what questions you're going to ask K2. So the way K2 can help you is first and most important is that you will have access to a predictive model that will tell you what your system is doing right now and what will be doing in the future under normal or emergency conditions. What will happen if you take tank offline in a very simple user interface. Hydraulic models have been able to do this for decades, but hydraulic models are extremely powerful tools, and expecting everybody to know how to use a hydraulic modeling software just to get a simple answer, what would happen when the pipe flows or what would happen if you increase demand at some point, is unrealistic. So the first and most important thing you get from K2 is a simple interface to predictions about system behavior. But then on the top of that, there are tools built into K2 that can help both operators and managers. So for example, for managers, if you have to make a decision of redevelopment in downtown, typically for something like that, you would have to go back to consultant and have them run the model and tell you what's the available capacity at this location. Now with K2, you can just click at the location, add the desired demand, and you will see what will this demand do to the rest of the system. You know which valves to close, which customers will be impacted by this valve closure, which customers might be downstream from this valve closure and will be isolated as well as maybe which customers will be impacted by the reduced level of service because of lack of pressure. And these are just simple examples of all the model predictions you can use in your decisions making. In my opinion, the change how we represent demands in hydraulic model will be the biggest improvement in hydraulic models in next 3 to 5 years. The same way GIS changed how we represent our networks. So today, nobody talks about skeletonization and everybody expects to have some kind of all mains model. We will have all demand models very soon through the links with AMI, AMR. Instead of using average day demand, instead of using maximum day demand, instead of using this simplified representation of the system, we will be able to accurately represent each individual demand to give accurate patterns representing the current day or current week. And the model overall precision will increase an order of magnitude, which in return then will allow us to make better predictions and make better decisions with these models. No model is perfect, and sooner or later you will come to a situation where the model tells you something that you don't expect. However, this is a great opportunity at least to improve the model, but often this is an opportunity to improve your understanding of the system. Because when some model tells you something that you don't expect, it might be because you don't know what's going on in the system. There might be closed valves in the system. There might be even closed valves on the major transmission lines. There might be connection between zones that you don't know about. So whenever a model doesn't match SCADA, that's the opportunity to improve the model, or even better, improve your understanding of the system. What is crucial for this to happen is that decision makers, operators, have to work in a collaborative environment with the modelers. If there's no collaborative environment, the only option the operator has when the model doesn't match reality is not to trust it and stop using it. But if there is a collaborative environment in which modeler can be notified and update the model as necessary, or work with the operator and decision maker to identify what is the misunderstanding of the system, then we get a better model and we get a better understanding of the system and better decisions. To have an environment where hydraulic model is used collaboratively, you have to allow each player to access the model with an interface that they feel comfortable with. The major problem that is currently in the industry is that we expect everybody to use extremely powerful hydraulic modeling tools to get model results. And that's unrealistic because these tools are very complex. So what K-Tune offers is simplified interface to hydraulic model results for the decision makers, where the modeler would still use their modeling tool of choice to build model, calibrate the model, and update the model, and then publish the model through digital twin, publish the model through K-Tune for everybody else to use. So the most critical part is the collaborative environment. K-Tune is a platform that provides operator with simplified access to hydraulic model results. And there are many uses where the operator can make better decisions, but just understanding what changes how changes they're making impact the system. So a simple one is, what would happen if I take tank offline, if I close a pipe? What if the pipe is broken and I have to isolate it? Within a K-Tune, the operator can very easily see which valves need to be closed to isolate the pipe, which customers will be directly impacted by this closure. Are there any customers downstream from this location which will also be without water? Or are there any customers that might be impacted by the changes this closure is causing to system and have a reduced level of service? Other examples are deciding if we can approve development at the location. In a K-Tune, you can add additional demand in any location and see how that impacts in a system. Traditionally, a decision maker would have to contact a modeler and very often reach out to a consultant to have additional run. And where this is a very simple run that takes less than an hour to do, for a consultant, since we are, as a consultant, delivering results, we need to write a report, document all assumptions. So this becomes $5,000-$10,000 project for something that's really point and click in K-Tune. Water Energy Nexus is a huge potential for carbon footprint reduction because water utilities operate like batteries. We add energy and store it in the tanks and then slowly release it. When there is excess energy or where there's cheaper energy, we can store this energy in a water distribution system. And second, we can make sure that our pumps are operating as close as possible to their optimal energy point. So we are using as little energy as possible when we have to use it. Because when you think of it, in most cases, we have to deliver a certain amount of water to a certain elevation. So you would think that the amount of energy needed to do that is fixed. But the time when we add this energy and the way in which we add this energy can be adjusted. So by using digital twins, we can choose to add energy when it's plentiful or cheaper. And we can also look at pump usage and optimize pump usage. So we use pumps closer to their top efficiency point. This question of water quality is particularly interesting in the United States because we have dual purpose systems, fire protection system and water distribution systems. And these two systems have different needs and different requirements. For fire protection, we want to store a large quantity of water, so we'll be able to fight fire and to have large pipes to deliver this water when there is fire. For water quality, we want to store as little water as possible so it doesn't sit in the system for too long, and have very small pipes so the water can move quickly through them. So balancing between water quality needs and fire protection needs, it's really tricky. Having a digital twin that will help you understand water age at any system, help you understand if you need the rechlorination and where, or how to better cycle your tanks. It's critical for managing water quality, especially if we want to manage water quality as cost effectively as possible.
K2.